Hello everyone, I am Syed Mushahid Hussain. In this demo video, I will be discussing the two lead code problems. Number one is the 1024, that is the longest duplicate substring you can see here. That is actually the hard problem of lead code problems. So this problem says, given a string S, consider all duplicate substring contiguous. Substrings of that S mean the string, that occur two or more times. The occurrences may overlap. Return any duplicated substring that has the longest possible length. If S does not have duplicated substring, the answer will be empty string. So guys, it says that we will be providing a string to this problem or this method, and we will find the longest duplicate substring in that string. All right, that string, the occurrences in that string may overlap. So here we have the example number one. So let's move towards the example, and the example is the word is banana. The string is banana. If we look at this string, B is on the first index, and that is not any other place, right? There is only one B, so we cannot consider B as a substring because we have to find the longest substring, all right, that occurs two or more times. So if we look at this AN, so in banana, AN, and we have another AN after that. So this is of two length. I mean, we have to check for the longest one. So if we look at this A and A, and it may overlap. So the first one is here, A and A. All right. So this will be the this will be the first string we consider the substring, and after that we can see here again A and A. It may overlap, so we can consider the previous A with the next one. All right. So if we look at this A and A is occur two times, so the output here is A and A. Similarly, for the example number two, we have a string A, B, C, D. So these are the distinct characters of this string. So it doesn't has any duplicated strings or characters. So we can simply return the empty string. All right. So there are constraints for this problem that 2 is less than equals to s total length, mean the length of the string, and less than equals to 3 multiplied by 10 power 4. So string can be of this length. Okay. S consists of lowercase English letters. Mean this is the precondition that this is the constraint that whenever you provide a string to this method, so that will be in lowercase. Okay, so actually this is the hard problem. I tried my best to find the solution for this, and I found the solution, and I solved this problem in actually C++. So here is the code that I have done. Understand the problem and solve it through C++. So I will be explaining the code to you, that how we can solve this problem. All right. So first of all, we can see here the longest duplicate substring method that has a string that are given actually. So what I have done here, I have find the length of the string for the first time, that is n equals to s dot size. Okay, so it will return me the size of that string that will be stored in this variable, that is n. And then I have created the first, that is 0, and the last, that is size minus 1, mean n minus 1. All right. So then, as C++ provides us the string views is also is a kind of view of string. We can view the string, right? So string view, C++ provides us. So I have used string views, and this variable is ans. That is my answer. That will be my final answer. Okay. So here I am telling to this that while first is less than equals to last, mean we have to execute the loop from the very first to the last index in order to find the maximum substring. All right. So inside this loop, I have unordered set, that is of string view, and is sv. Okay. So this is actually unordered set I have created for this string view in order to perform a better. Uh, then I have created here a mid. So I have to be jump in the mid of that string in order to compare the substring of that string. All right. So the mid is actually of the first plus last divided by 2. So that will be given as to the mid index uh, of that string. All right. So uh, and then I have here initiated a boolean variable found. If I found the substring in that string, then the boolean variable be the found will be assigned as true. And similarly, inside the while loop, I have to execute a for loop because I have to check character by character, or we can say we have to take a substring a position by position. So that's why I have put here a for loop. So inside the for loop, the for loop will be executed till the n minus mid. Mean we have to check in the first substring, and then after the next substring, and then after the next. Okay. Till the end of this whole string. So inside that we have a constant auto it and inserted from the sv, that is there where the sv is the string view of another set. And from inside the sv we have in place the string dot data, that is the original actually string known as s. Okay. Yes. So this is the capital S. Okay, got it. So the data will be in place in this const auto, and in this string view, and then we will check here if not inserted. I mean, if there is nothing inserted, so we will say it that we have a found that character, and that character will be in it, the pointer it, the index or the character pointed by it. So that will be assigned to the answer, and we will break the for loop. So this break will execute, and it will come out of the compiler will come out of the program will come out of the for loop. All right. And inside this while loop, we will check if found, mean if found is true, then the first equals to mid plus 1. Else, if found is still false, then the last will be equals to mid minus 1. Mean we will be checking in the previous substring. All right. If we have found, then we will check it from the next substring. All right. So after this whole execution of the while loop, mean to the length of the string, and then we will return the answer dot begin and answer dot end, mean that substring will be returned by our program. All right. So that was the program of the longest duplicate substring. So now we have to run this program after running this. Okay, there's a compiler error on line number 24. Okay. So we will run it again. Yes, it accepted, and we are going to submit it. Actually, the internet is not that much good, so it's accepted. So this was the solution for this problem. So here we can see that this is accepted, and we have here the runtime is of this millisecond, and the memory is used here uh, 250. So there may be the optimum solution for this problem, but this was my solution for this problem. And if we dig down this problem, and if we more understand the problem, and if you are good enough at the programming, you can provide the optimized solution more than this. So this was my solution. Now moves towards the second problem of this lead code problem. So here we have another problem of this lead code problem, and that is the problem number 862, that is shortest subarray with sum at k. So this is also the hard problem of the lead code problems, and it says given an integer of array nums, the number array, and the integer k, return the length of the shortest non-empty subarray of numbers, that is nums, with the sum of at least k. If there is no such subarray, then return -1. And subarray is a contiguous part of an array. So actually this program says that we have to find the sum of subarray, that is the shortest subarray of, I mean at least we have to sum the number of elements up to k. The k is given here. So to the k, from the index to the k, at least we have k elements, the sum of k elements, that is in that array, and that will be called a sub array of the array, and we have to find the sum of that array. All right. So if we look at the example number one says that the numbers array is 1. Okay, and the k value is also 1. So we will make a sum of 1 index in that array, or one element of that array, and that array has a length 1, so the output will be 1. Similarly, if the array has length 2, there are two elements in that array, that is 1 and 2, and we are provided the k equals to 4. So there is not 4 elements in this array. So in this case, we cannot find the sum up to k element. Okay, we cannot I mean we cannot sum this for the misery elements that are not present here. So we cannot sum that element. So that's why the output is -1. And similarly, the example 3 says that the elements are 2, -1, and 2. And we are provided the k equals to 3. So we have to sum the elements, at least 3 elements. So we will then there is a total element 3. So we will make the sum of that and return it. So 2 minus 1, that is 1, plus 2 equals to 3. So the output is 3. All right, so we have some constant here, and that says 1 is less than equals to nums dot length less than equals to 10 for 5. So the length must be in this range of the array, and the indices can be from minus 10 power 5 less than equals to nums of I less than equals to 10 power 5. So the number nums of I, the elements can be between this range, that is minus 10 power 5 to 10 power 5. And similarly, we have constant for k. The k will be in between 1 and 10 power 9. So actually this is the hard problem. I tried and I solved this problem. So now I'm going to explain the code of my problem. So the code is here, that we are given the shortest sub array. All right. So here, right. So we have in this shortest sub array method is nums of the array, that is nums, and the k value. All right. So first of all, I'm getting the size of this array, so because we have to go to the size of that array, and we must know the size. Okay. So and then I have here there will be the final output or the answer of my program. So I've initiated ANS as the answer, and initially it is the n plus 1, mean the size plus 1. So actually that is not here in this because we cannot consider it. So that's why it's n plus 1. And here I used for this problem is a double-ended queue. So in order to we can check from the from the beginning and as well as from the end, we can pop or push from the front or from the rear. So that's why I've used the double-ended queue, that is DQ, and the vector prefix, and the prefix is of n plus 1. All right. And next I have a for loop for this program, and the for loop is here just to fill the prefix, that we will store all the prefixes in this prefix, that is prefix of I plus 1 equals to prefix of I plus numbers of I. I mean the elements that are in number will be assigned to this. And then again I have a for loop to check the to check the sum of that elements, the subarray, the shortest subarray. So here is the while loop inside the for loop, and it says if q is not empty, all right, and then prefix of I minus prefix of q of front greater than equals to k, mean we have to run the loop until the elements or goes up to the k, or the becomes an empty queue. All right. And inside that loop, I have said that I've assigned the answer to the answer, that's min of minimum. So minimum of answer and I minus q of front and q dot for front. Okay. So this will be return the minimum and that will be assigned to the answer. And again, if we check there the answer and inside this for loop again it will comes to the next while loop and it will check if not q dot empty, mean the q is not empty here, and prefix of I less than equals to prefix of q dot back, mean if we are not reached to the end of the prefix. All right, that is q dot back. And inside in this we are going to pop back the q and then push back the I, mean we are pushing again into the queue the that element. All right, so that we can sum that element, we can we can get the you know we can get the length of that element. Okay. mm, yes. Okay, so finally after that for loop, if this for loop ends, we are returning the answer less than equals to n, then return the answer, else return -1. If if it means if we are given the k greater than from the elements, so in that case it will be returned -1. Otherwise, it will be returned the answer that we have find. All right. So let's run this problem. Yes, it is accepted in the cases of one, and let's submit it. Okay, it is accepted. So the runtime for this problem is 505 millisecond and the memory is 104.9 MB, and that beats the 77.56 submissions. And in due to and in runtime it beats 37.65% of the submissions. So this was this was a actually optimized solution, but it can be more optimized than that. So hopefully you got the solution, and yes, that is, thank you, and thank you for this this listening this this kind of demo, and that we are given to this problem. Actually, these are the hard problem lead code of the lead code problems, so that cannot be solved easily. So this was a quite good solution for this problem. So anyone who wants to solve the lead code problems and they face any issue in that, so they may check these answers. uh, yeah, good luck and thank you so much.